Alright, B's and G's, welcome back to the drive-through special pre-spring break edition of Drive-Through Confessionals. We're talking about law of cosines today. We've been doing law of sines for weeks, okay? So, the first thing I want you to learn is when can I use the law of cosines? And if you think back to your days in geometry, maybe you remember these things called SAS theorems and SSS theorems. And they describe situations where you know two sides and the angle included between them. This is your SAS scenario, where those letters stand for side, angle, side. Okay? The other scenario that you can use it is very simple. If you know all three sides of a triangle, then you can use the law of cosines. So, SAS and SSS are going to be when we use the law of cosines. There's actually three laws of cosines, but they all look like copies of each other. So, I'll write them out for you guys today. You're going to get used to writing these. It's not as much about memorizing this equation as it is about understanding when to use it and how to use it. So, a squared is equal to b squared plus c squared minus 2bc cosine of a. So obviously that's fairly complicated and involves a lot of variables, so you don't want to get intimidated. Okay? Once again, our lowercase letters are going to be side lengths, and our uppercase letter is going to be an angle measure. So our second equation will be b squared equals a squared plus c squared minus 2ac, give myself a little space, times the cosine of b. Okay? And then the final law of cosines will be c squared is equal to b squared plus a squared minus 2ab cosine of capital C. So those are the three law of cosines, or the three laws of cosines, but you can see that they're just repetitive versions of each other. We just got to identify when to use which one and how to manipulate them. Okay? Alright, so let's look at an actual example. What we'll probably be asked to do is to solve the missing triangle. Okay? So, notice we could not use law of sines here. There's no way we could use law of sines. So we're going to have to use law of cosines one time, and then we'll use law of sines. So we'll just call this A. It doesn't matter what we call. So that has to be A now. That matters. So the lowercase letter needs to be across from the proper angle. So if I call that B, that makes this B. And then that makes this C, and a little C there. Okay? So, for this one, are going to say a squared. We know b and c, and we know capital A. So a squared is equal to b squared plus c squared minus 2bc cosine A. Now this is the easy version. So when you're given SAS, that you should be happy. That's the easier version. Watch what's going to happen. You're going to have a squared equals, 27 squared plus 22 squared minus 2 times 27 times 22 times cosine of 47. It's beautiful. Look, we know all of these variables. Okay, so all we have to do is learn how to type that into our calculator, right? Remember, that's going to give you a squared. So we have one more step. So here we go. 27 squared plus 22 squared minus 2 times 27 times 22 times cosine of 47. And that gives us 402.8. Square root that. And that's going to be 20.1. So A is 20.1. Now we can use the law of sines. It's much easier. So now we can say sine of 47. I'll switch to blue. Blue is indicating that I'm using the law of sines now. Sine of 47 is to 20.1. Like the sine, it doesn't matter. I can pick which one I want. I'll just do B. Like the sine of B is 2. Now notice that B matches up with 27. So now the sine of B is equal to 20.1 times, I'm sorry. It's equal to 27 times the sine of 47 divided by 20.1. So I get sine of B, this is a big number, is 0.9824. Let's take the sine inverse of both sides. And you get B is 79.2 degrees. So now I know this is 79.2. And so now I can just use my triangle sum to find C. So I do 180 minus 47 minus 79.2. And the remaining angle is 53.8. Now, just like all triangles, I can check to see if I did this right. So look, biggest side is 27. The biggest angle is across from that. The smallest side is 20, and the smallest angle is across from that. Notice that these sides are relatively close to each other, C and A, and angle A and angle C are also relatively close to each other, and that's how you know you did it right. You just check it with some common sense, okay? So, that's the first version, when you're given the SAS. The SSS is going to be a little bit tougher, so let's do that one. We've got to call these things, so doesn't matter what we call them, but now we know that that's A, this one's B, and this one's C. So, it doesn't matter which one we use, so I'll say A squared. Oh man, I don't know what's going on with that. Is equal to B squared plus C squared minus 2BC cosine of A. Alright, now look. In this, when you've got the side example, the algebra is a little bit more difficult because you're going to have to maneuver things. But you can do this. You've been doing it all year, working on your algebra skills. This is why you took 2 algebra classes prior to pre-calc. So, you'll say 29 squared is equal to 48 squared plus 31 squared minus 2 times B, 48, times C, 31, times the cosine of A. Okay, so in this equation, we are going to find capital A. It's going to take some work. So, what I will do is subtract 48 squared and subtract 31 squared from both sides. So what I'm about ready to type into my calculator is 29 squared minus 48 squared minus 31 squared. It's going to give us a negative number, and that's totally okay. So what I have, I've subtracted that and that from this, and over here I get negative 2,424 is equal to, and then I still have all of this in here. So it's equal to a negative 2 times, well, let's clean that up. Well, no, I won't do that. I'll write down every step. Okay? So we're trying to get cosine of A by itself. So now we will divide each side by a negative 2 times 48 times 31. So those are all going to be gone, but I got to divide this by negative 2 times 48 times 31. So I'm going to type in my calculator, negative 2424 divided by parentheses negative 2 times 48 times 31. I'm going to close my parentheses, and it's going to say 0.8145 is equal to cosine of A. Notice how those two negative signs canceled each other, and so we got a positive cosine of A that's less than 1. That's what we want. Take the cosine inverse of both sides. That's how we get rid of cosine. And we get A is the cosine inverse of 0.8145. And that is 35.5 degrees. The calculator is probably where you're going to make your error. Okay? Now I can use law of sines again. So, sine of 35.5 is to 29, like sine of C is to 31. Sine of C is equal to 31 times the sine of 35.5, okay, divided by 29. You get sine of C is 0.6208. Second sine of both sides. And you get C is 38.4. And now to find B, I'll just subtract that from 180. So 180 minus 35.5 minus 38.4. And you get 106.1. Now let's check ourselves. 48 is the biggest side. It's across from the biggest angle. That's 106.1 degrees. Okay? These two are really close. 35 is smaller, and it's across from the 29. And once again, I know that I'm doing it right. So definitely some hard work on this, but you guys can totally do it. And we'll get started, and I'll give you the help you need right now. Boom!